SHMs, welcome back to another video. This is the question bank series. This is the ultimate grind for BITSAT 2025. With every episode of this series, we are strategizing and we are battling out about 10 questions. Okay, so you are getting with every episode 10 questions stronger for your attempt in BITSAT 2025. So today we are discussing the chapter of simple harmonic motions or simply small oscillations. So you know the drill. Firstly, we discuss the previous year trends. We see which topics in this particular chapter are favored or preferred or frequently asked in the previous year for BITSAT. Okay, so you know which topic to focus on, and then we practice about 10 questions on the lines of those topics. Okay, so let us see which are the important topics to focus on in SHM. So firstly, we have questions being based on your time period. So small oscillations, you have those. You can write f is equal to minus kx, and then from there you can have the time period of that particular small oscillation, right? So we'll come to the question. So this is one of the most important topic. 13 questions were framed from the simple concept of time period of SHM. Okay, then again from the simple concept of your displacement equation, x equals a sin omega t. From there also we have 10 questions. Okay, so just a simple equation you are supposed to know, and you can get around a lot of questions done with that. Then we have questions on the graph, maybe on the graph of kinetic energy and potential energy in terms of your SHM. Then we have also questions on combination of SHM, one question each in those two topics. Then we have questions which were miscellaneous, basically questions based on resonance, which we'll do in the chapter of waves next. Okay, so those questions are added over here. So that's about the previous year trends. Let's dive into action and let's fight out the questions now. 1 and 2 we have over here. Okay, so in question 1 we have been given an SHM equation, rather a combination of two SHMs. So they are in centimeters, so be careful about the units. We'll see this time and again in the subsequent questions. Okay, so then you are supposed to tell the amplitude of this SHM. Okay, so we also have 3 and 4. Okay, you can't report any one of those or they are average. We have to find a way, right? So y is 3 sin omega t. Now we can bring it all in terms of sine, right? Or you can bring it in terms of cos, whatever you do. So this cos, I'll bring it in terms of sine. So sine pi by 2 plus theta, right? So sine pi by 2 plus theta is cos theta, right? Sine in the second quadrant is positive, pi by 2 plus theta. So theta is omega t over here. So that works out. Okay, you don't have to change the sign because sign is positive in the second quadrant. Then now we can compare, right? This is sin omega t and this is sin omega t plus this angle, right? So what is the phase difference between these two SHMs? So if we have 3, suppose sin omega t in this direction, then the phase difference 4 will be in this direction, right? The amplitude, because the difference between them, the phase difference is of pi by 2. Okay, so if 3 is like this, 4 will be like this, and you can find the resultant now by triangle law. This will be nothing but 3, 4, 5, right? Or you can use the vector relation, a1 square plus a2 square. These are not actually vectors but phasors. So anyways, so theta is 90 over here, so this will go to 0 and you'll basically have under root of 3 square plus 4 square, which is nothing but 5 square, 16 plus 9, right, 25. So that is 5, under root of 25, 5. So the correct choice over here is option D. Okay, so that is how you tackle a question based on combination of SHM. You bring it in either all sine or all cos, and then you see the phase difference. Use the addition of vector formula. Let's come to this one. Here we are given this SHM, okay, and it is in SI unit, meaning x is in meters, right, not centimeters. Then at t equals 1.5 seconds, you are supposed to tell the acceleration. Okay, so we have x is equal to 5 cos 2 pi t plus pi by 4, right? You are supposed to tell acceleration, so we can differentiate it once, differentiate it twice, and we'll get to acceleration, right? Or the best thing we do over here is acceleration. You know it in terms of your SHM is minus omega square x, right? This is the famous equation which every SHM will satisfy. So minus omega square, omega is what over here? You can compare a cos omega t plus phi, right? So omega is nothing but 2 pi, right? So minus 2 pi square, and you just copy the x, 5 cos 2 pi t plus pi by 4. Okay, those who don't know about this formula can uh, differentiate this, you'll get velocity, again differentiate it, you'll reach to this particular formula. Okay, so here we'll have 5 into 4 into pi square and cos. Now let us substitute the value of t that we are given. So 2 pi into 1.5. So 2 into 1.5 is 3, right? So 3 pi plus pi by 4. Okay, pi I am keeping as it is because we can see 2 pi will complete the particular circle, right? 3 pi will be over here. So 3 pi is over here plus this pi by 4 plus pi by 4 is over here, right? So you can see that it is in the third quadrant. Third quadrant, tan is positive, cos is negative. So cos of, so this will be 20 pi square, cos of uh, 3 pi plus theta is cos theta, okay, minus cos theta, sorry, because it is in the third quadrant. Okay, so minus minus will make it plus, so 20 pi square, and cos pi by 4, cos pi by 4 is 1 by root 2, right? So once you calculate this, you'll reach up about 139 point something something, okay, so which is very close to 140, and it is in meters per second because we have the answers in SI unit, right? So that is your answer. Okay, it's not 140 centimeters per second square, it is the x is in meters, right, in SI units. So option C is your correct choice. Over to the next question. So question 3 and 4 over here. In question 3, we are given again the equation of SHM, general equation. You are supposed to tell the value of x for which the energy, the kinetic and the potential energy will be equal. Okay, so some of you might directly know this answer. It is x it is not this one, sorry, it is a by root 2. Okay, at a distance root 2 of the amplitude, the kinetic and the potential energy are equal. How do you go about this question? Actually, this was one of the questions that we did in our class in 11th standard, so that's why I remember the answer directly, and you can remember it too because it is a very general question. So what are we doing? We are saying that the kinetic energy should be equal to potential energy. In SHM, we know potential energy is half kx square. Also, we know total energy is half ka square, right? When the amplitude is a, so at the extreme point, basically the total energy is nothing but the potential energy, right? So when the x is not equal to the amplitude, the total energy is half ka square, right, which is totally potential, okay, at the extreme point. Okay, the velocity becomes 0, right? So kinetic energy becomes 0 at the extreme point, and it is purely potential, which is half ka square. Now this total energy is constant, so you can write kinetic energy in terms of total energy minus your potential energy. Okay, this is a particular way of doing this question. So you can write this half ka square minus half k x square, right? Total energy half ka square minus potential energy half k x square. Now these two are equal. Okay, now this is, you can remember this as one of the formulae for your kinetic energy. Okay, so you got it from T minus V. Okay, so now this is your kinetic energy, right? So we are equating it, so k cancels, half also cancels, so you'll get a relation. Now this a is small in this question, so a square minus x square will give you x square, so 2x square is a square, so x is nothing but plus or minus a by under root 2, right? 2 will come over here and you take square root on both the sides, so a by under root 2, so 1 by root 2 of the amplitude is the position where kinetic and the potential energy are equal for a SHM. Okay, you can remember this as a general result. Okay, let's come to this one. Here we are given the kinetic energy versus the kinetic energy variation with x. Okay, and the mass of this body performing SHM is 1 kg. You are supposed to tell what is the time period, okay, the period of oscillation. Now I told you at the mean position the kinetic energy will be maximum, right? At extremum it is 0, you can see the energy will be totally potential. So at the mean position at x is equal to 0, it is purely kinetic. Okay, so kinetic energy will be equal to the total energy, and at the extreme position potential energy is equal to total energy, and hence it is constant. Okay. So what will be kinetic energy now? It is equal to total energy, which means it is half k a square. Okay. Now amplitude you can make out from this question, right? So the maximum distance in x is the amplitude, right? What is the amplitude? 0.5. What about k? How can you tell k? Now this is kinetic energy, and this k is spring constant. Okay. Now spring constant you can write it in terms of k is equal to m omega square. Okay. So I hope you know about this. We'll also come back to it when we discuss in more detail about a time period for different bodies. Okay, in SHM. Okay, we'll come back to that. But for the time being, you remember the spring constant is m omega square, or you might also remember it in this form, m by k. Okay, which will be useful in the case of finding the time period. Anyways, let's come back to this. Uh, so now k is m omega square. From here you can find the time period, right? You are supposed to find the period, which is t. Now t is nothing but 2 pi by omega. Okay. Now that is what I was mentioning. Now this is a side note. This is not related to this question. Of course, we are supposed to find time period. Now what I'm doing is not related. So from here you can find m by k, right? So this is the time period formula that we use for SHM. This is how it is basically derived. Okay. So let's come back to our question. We are supposed to find the time period. So once we know omega, we can find the time period. That is sure. Okay. Now kinetic energy, we are calculating it at mean position, right? X is equal to 0. So x is equal to 0, half k a square. Okay. Also by the formula you can see. So now kinetic energy at the mean position is 2, right? 2 in joules. So you just substitute the values. So 2 2s are 4, and m is 1 omega square, and a square, what is a? It is 0.5, right? So 0.5 square. Okay. So that is half in the denominator, that will go in the numerator. So 4 4s are 16, right? Omega square will be 16, or basically omega will be 4. Okay. So omega is 4. You are supposed to tell the time period. Time period is 2 pi by omega, simple. So 2 pi by 4, which is pi by 2, right? 4 and 2 will get cancelled, and we'll have pi by 2, which is option A. So that's the simple concept behind this question. Over to the next one. So question 5 over here. A lot has happened since the previous time I was recording this video. My phone fell and lost its display, so I had to recover it, repair it, and now I am recording this video again. So I didn't quit on this video, so you should not quit over here. Okay, so keep fighting. Let's get through it. So here we have question 5. So here it is, firstly we suspend this mass by the spring K1, then successively we'll suspend it by K2. Okay, so K1 it has a time T1, and K2 it has a time T2. So firstly we do this. So the same mass m hung by K1, and then you do by K2. So this has time period T1, the other one will have time period T2, and finally in this configuration as shown, so the time period is given as T0. Now you are supposed to find the relation between these three times. Okay. Now the simple formula for time period that we had seen is 2 pi under root m by k, right? So in this first case, it's simply 2 pi under root, mass is same, k1 will have, right? There is no k2 over here. In the second case, we have 2 pi under root m by k2. Okay, so second case we are hanging the mass by this spring of spring constant k2, and then we have this combination. Now what is this combination? This is a parallel combination, right? So in parallel combination, the spring constants add up, right? It's like your capacitance. Okay, so here 2 pi under root m by k effective. Okay, so here we have two springs, so we will take the effective k, right? So in parallel combination, I told you it will be the sum of those two, k1 plus k2, right? Now you can plug each of these values in each of the formula and check which one will give you the right answer, or you could do it wisely, right? So this is T1, this is T2, okay, and we have T0. Okay, so we know that the denominator should become, this should become sum, right? So something like 1 upon, right, that should become sum, and it should be squared, right? Only then we can add, right? So let me do that. So I'll take the reciprocal of this and square it. Okay, So basically I want this and this to add, right? That will give us this result, and we want it in the numerator. Okay, denominators don't just add, right? They multiply, and then you have all the LCM HCF rules. Okay, so here we know that numerators add, so we'll bring this to the numerator, bring this to the numerator, square it, and then we can add, right? So that is the logic. So here I can square this, so I'll have 1 upon, right? So 1 upon 4 pi square, and here you will have upon 4 and k1 plus k2. Okay, so I can write it as so I'll split it so you can see it more clearly. So this is k1 by m plus 1 upon 2 pi square k2 by m. Okay, actually the answer was visible from here only, it's inverse of squares, right? This one is the answer, so we are verifying that. So if you see this is nothing but 1 by t1 square, right? 1 by t1 square. So if you take the reciprocal and square it, you'll have k by m and this 2 pi in the denominator and square, right? And this will be 1 by t2 square. So the correct relation that I told you is this one. Okay, t naught will be t naught raised to minus 2 will be the sum of t1 and t2 raised to minus 2. Okay, so that's about this question. Over to the next one. To question 6 and 7 over here. In question 6, we are supposed to tell the potential energy of a simple harmonic oscillator when the particle is halfway to its endpoint. So basically at x by 2, so or the amplitude by 2, you are supposed to tell the potential energy, right? The potential energy has a simple formula in SHM. It is half kx square. It's half k, and we know that the total energy first of all is half k a square, right, at the amplitude. So the total energy of SHM is half ka square as previously discussed. So x square, here x is a by 2, right? At a point half its endpoint, endpoint is the amplitude, right? So at that point x is a by 2. So at this point we are supposed to find the potential energy in terms of the total energy E. Okay, so this is half k a square. Now 2 square is 4. So if you see, this is nothing but total energy, right? So this is 1/4 of the total energy, right? So this is the point where the potential energy is at x, at a by 2, the potential energy will be 1/4 of the total energy. Okay, so let's come to this one. Here we have a block placed on a smooth inclined plane. It is attached to 2 springs as you see. Okay, and each of them has a force constant k. You are supposed to tell what is the time period of this oscillation. Now we know one formula for time period in SHM, and that is this 2 pi under root m by k. Right, here it will be k effective since we have a combination of springs, right? So what is this combination? Okay, this combination, is it series or is it parallel? Looks more like series, but in fact it is parallel. Okay, so the reason for this is something that you will tell me in the comment section, and we have discussed such type of questions. I think even in the ACE series we might have discussed one such questions, or even in the mock test. Okay, why is this combination a parallel combination? Okay, so this is actually, okay, so it is a parallel combination. You tell me why. So what is the formula for parallel combination? It is 2 pi under root m by k. K effective will in parallel will be, so in series we know that it just uh, in parallel it will just add up, right? K1 plus K2, right? It's opposite to that of resistance, so K is equal, so 2K will get. So this is nothing but 2 pi under root m by under root m by 2K, right? So which is in option A. So that will be your correct choice, although I have left you with certain homework or a thing to ponder about, and let's see who answers that in the comment section. The correct answer will receive a heart from me. So that's about question 6 and 7. Over to the next one. We have question 8 and 9 over here. Question 8 is based on the projection of your circular motion. So projection of circular motion gives you SHM. It's a very interesting concept. I have a whole video dedicated to it. If you are interested, I'll link it down in the description box below. Okay, so you'll know how SHM is related to your uniformly circular motion. Okay, so for the time being, we'll see how this y you are supposed to tell. Now this particle at t is equal to 0 is on the y-axis, as you can see, this has a time period of 4. The circle has a radius of 3 meters. You are supposed to tell the projection of this radius vector rotating particle P will be. Okay, so the projection of the circular motion of the particle will be a SHM. You can see, right, A sine cos omega t. Okay, so basically the projection of uniform circular motion is your SHM. Okay, let's come to this question. How will we find this? So if you see at t is equal to 0, where is the particle? Now we are supposed to find in terms of y, right? So projection is on y. Okay, so basically you are shining a light on this particle from the x direction, so you will get a shadow on the y-axis. So that is what is meant by projection, right? So at t is equal to 0, you'll see that the particle is at its maximum, right? On the y-axis, the particle has its maximum displacement, which is the amplitude. Okay, so it is cos form, right? So it will be of this form, a cos omega t, because cos 0 is 1, right? Cos begins like this, it begins at the maximum. So at t is equal to 0, on the y-axis, the particle is at maximum. So we'll have a cos type of function. Sine type of function will say that at 0 it is 0. But here in this case, at t is equal to 0, the displacement in y is maximum. So we are saying the function will be of the form a cos omega t, because it is maximum at t is equal to 0. Now, how will we find omega? Omega is related to time period, right? 2 pi by t, or t is 2 pi by omega. So you get omega like this. So 2 pi by t. T is given 4. So this will give you pi by 2. And simply you have your answer. And what is the maximum amplitude? It is nothing but the radius of the circle, right? This will be also 3 meters, right? So 3 into cos of omega t. Omega is pi by 2. And you'll have t, which is option A. So it's based on the concept that I mentioned, and it's very simple, right? So if you want to get to know the insights, you can check out the video in the description. So let's come to this one. Here we are given the displacement time graph in terms of x and t for a particle which is undergoing SHM. So from the figure you are supposed to tell the displacement equation. Okay, it is given that the time period of this particle is 2 seconds. Okay, so this will be 2 seconds. So you can see, so this is 10 over here, this peak is 10. Okay, now what can we say? So basically the amplitude is 10, right? So that is the maximum displacement in the x direction, so that will be 10. Okay, now is it sine form or is it cos form? Okay, now you might argue that it is starting somewhere in between, right? It's neither maximum nor minimum, so it has some sort of phase difference. Okay, so we'll assume, okay, let's see where we reach. We'll assume x is a sine omega t. Now a we know it as 10, so a sine omega t plus some phase difference phi. Okay, that is induced. Okay, so it should have begun from t is equal to 0. Okay, it should have begun like this, right? But we have shifted the phase, so it is slightly beginning from some other point. Okay, so you'll see that at t is equal to 0, now t is equal to 0 is over here, right? So t is equal to 0, we already have x as 5 centimeters. So you can substitute that and you'll obtain this phase, right? Now omega is 2 pi by t, right? So here you can substitute t as 2, so omega is pi. Okay, so now this will substitute at t is equal to 0, the displacement is 5. So 5 is equal to 10 sine omega is pi, this is t is 0, right? Anyways, that does not matter. So omega t, that will be 0 since t is 0, and we'll get 5. So we'll find phi as 5 by 10, which is half. So which means your angle is 30 degrees, okay, or pi by 6, right, in radians. So x will be 10 sine omega is pi t plus 30 degrees, which is pi by 6, okay, which is option A. Okay, even if you had begun with the cos function, you would have again reached out to the same answer, maybe in the cos form. Then you'll have to change the ratio by pi by 2. Okay, so that will again give you a sign, so that way you would have again ended up at the same option. Okay, no worries over there. So that's about this question. Over to the next question. Question 10 over here, basically it mentions that the surfaces are ideal, smooth, so there is no friction over here. The distance between this block and the first spring is L, and so is the distance between this spring and block. Okay, so spring constants are given. This block will be given certain velocity v0 in this direction. So you are supposed to tell what will be the time period. Okay, so now we can break this question into three parts, the system in three parts. So first of all, there will be motion in between, there will be time period due to that. Then the block will compress this spring, right? So there will be some time period due to that spring. Okay, so we can say T1, then T2 and T3. Okay, so this spring and the motion in between. Okay, all these time periods will contribute to the final time period of the system. Okay, now let's break it down. So for this spring, okay, so let's call it T1. So first of all, this block will go. So the middle part will omit for now. We will come back to it at the very end. So the block first goes and compresses the 4K spring constant one spring, right? So for that, the time period will be T by 2. Okay. Now why T by 2? Because if you see what is time period? Time period is, suppose if you take this as reference point and the block is going in SHM. So suppose this is the extremum and this is the reference point that you are taking. So the block, suppose it starts somewhere over here, it comes to this point, goes back and comes over here. Okay, so this is the time period, right? So what will happen in this case? So the block has to touch once, go back and come back, right? So that it should complete one cycle, right? So what will happen in this case is the block will go, compress the spring, come to the reference, suppose this is the reference point, block will go, compress the spring, come back to the reference point and never go back, right? So you'll only consider half of the time period, not the full, right? Full will be the complete cycle. Okay, just picture this, compresses the spring, comes back, goes back and again comes back. This is a complete cycle. Whereas what is happening in this case is it goes, compresses the spring, it's not tied to the spring, so it after the spring releases it, it goes to the other side. So only half the time period of the spring is contributing, half the cycle, right? Similarly for the spring, only half the time period of it will contribute because the block is not tied to the spring. Okay, so let's come to this question now. Now what is the time period with this spring? So it will be again that formula we know, 2 pi under root m by k. K is 4k over here, right? So this 2 you can cancel and this 4 you can take out and you'll have pi by 2 under root m by 2. Now T2, for this spring we can write again, it stays for half of the time period of that spring, so half 2 pi under root m by k, right? So this and this will get cancelled, pi under root m by k. So pi and pi by 2, so 1 and half, so 1 and half, so you will see 3 pi by 2, right? So either this option or this, others you can neglect or eliminate. So we'll have this. Now there is one more time period, right? The motion that is happening in between, right? In between the springs, which is where the block is not tied to any of those springs. Okay, now how will you find that time period? Basically distance upon time, right? So if you see what is the distance that it is covering, it is not 2L. Okay, mind you, I told you time period is going like this. Okay, you go to the, suppose we take this as the starting point, this as the end point. Okay, this is the starting point, this is the end point. Okay, so the block has to go like this. So this is not the complete time period, it has to come back, right? Suppose this is the reference, okay, and this is the end. So go over here and come back to this point, that will be the time period. Okay, so here how much distance is it traveling? So 2L in this direction and again 2L. Okay, so time is equal to distance upon speed. So it won't be 2L, sorry, it will be 4L, right? 2L plus 2L, 4L. So once you add this, so this will give you 3 pi by 2 and this will be 4L by V0. Okay, so this is the answer, not this one. Okay, so that's about today's video. I hope you really enjoyed it and got to know about a few things, and we'll continue with the series and continue with the grind for BITSAT 2025. If you want to get into bits, this is the channel that you're supposed to follow. Do consider subscribing if you made it this far, because the grind is going to continue and we'll come up with more stuff for BITSAT 2025, and make sure you don't miss out on that. Okay, so With that being said, I'll see you soon in the next video. Till then, keep enjoying physics.